I am walking in the hills, the Western Hills, near Wellington in New Zealand. That's the harbour over there behind me. What I want to do is tell you what these hills are actually made of. Mostly you can't really see because they're covered in grass, but in places there are rock outcrops, and what you see when you come to those is very weathered bedrock, brown grey coloured sandstone, sometimes mudstone, and it's the story of that rock that I want to tell you in this video. So I think the best way to explain these rocks and their history is to show you some pictures and talk you through them. So, first of all, this is a map of the same rocks that we've just seen on the hills across New Zealand. So the geologists have mapped this over many years, and they find that this Greywacke, this sandstone and siltstone, extends right through the country. So it's, if you like, the backbone or the bedrock of New Zealand. It's New Zealand's national rock, you could say. So it's a very important rock, and it's not only on the land of New Zealand. If we were to sort of dig under the surface and look beneath the vegetation, we would find it in these areas, but also we can actually know that it extends out into the ocean as well. This image here shows a kind of impression of what you would see if you stripped away all of the ocean around New Zealand. So there's New Zealand in the middle, but this orange coloured shape, it looks like a sort of maybe a wing or a triangular shape around New Zealand, is an area of rock which includes a lot of that similar sandstone and mudstone. So in other words, New Zealand is the tip of a huge area of this material, and this is continental rock. It is not the same as the deeper crust here in the oceans, which is the blue colour, which is a different type of material. It's basalt. So where did this huge area of rock come from? Because when we answer that question, we'll answer the question of where did that individual rock come from on the Western Hills. Firstly, we know that it's continental rock because these red marks on the map here are samples that have been taken from under the ocean by drill ships, or sometimes from little islands around the place, which show this particular type of rock. So we know that this rock extends beyond New Zealand. To another view, you might just see a pink outline that shows you the outline of this area. It is about 17 times the size of the land of New Zealand. So it's a hidden continent. And how did that arise? So this map shows the situation when Australia and Antarctica were joined up as part of Gondwana, or Gondwana land. And you can see that out here in the Pacific, on the eastern side, there's this huge kind of greenish colour, and it's named Zealandia. So what this area is all the mud and sand that has been washed off the coast of Gondwana is washed out into the ocean, and it's sort of sitting, if you like, on the ocean floor. And at this time, Australia is joined to Antarctica, and this material is being washed off the coast. And this situation lasted for something like 400 million years. Along this line on the coast of Gondwana, there was a subduction margin. In other words, the Pacific Ocean was being pushed into Gondwana and underneath it. And so there was a lot of uplift along the coast. There was erosion of the mountains. There was lots of sediment pouring into the ocean, and it was all being pushed and scrunched up against Gondwana as well. So these rocks tend to be highly deformed when we find them. So this image here shows the subduction happening before it stopped. So this is the Pacific plate pushing into Gondwana, the rocks getting deformed, some of them being dragged underneath, and then on Gondwana there are mountains, there are volcanoes, and this is a highly active subduction margin, very similar to what we might see today on the North Island on the east coast of New Zealand. So over time, this long-term situation of the past, it actually eventually stopped. And instead of the Pacific Ocean pushing into Gondwana in this way, which it had been doing for so long, it actually stopped, and instead it started to split apart. So this area called Zealandia, this ribbon of continental sort of sediments, started to drift away from Gondwana. So I'll show you a series of little maps which just shows how Zealandia separates from Gondwana. The blue line represents a line where the separation is going to start happening. So you can see that the Tasman Sea starts to open up, it gradually gets wider and wider, and then you might notice this shape here, which is, if you like, bits of modern New Zealand. They're not quite joined up in the same way that they are now, but you can see a black line coming through, and that is the modern plate boundary developing. So if I keep going, we're now in a situation about 20 million years ago where this plate boundary is now pretty much fully developed. The South Island is up against the North Island, and it is going to be dragged southwards along the Alpine Fault so that the east and the west coast of the South Island line up as they do today. So that's the final modern situation. So we have a new plate boundary. Australia and Antarctica have now separated. Zealandia has been pulled away and separated from what had been Gondwana and is now Australia and Antarctica. So that's our modern situation, and if I just show you a little bit of a detailed map of what New Zealand looks like in the setting of the remains of Zealandia around it, you can see we've got the plate boundary coming right through the country, the Alpine Fault, and then it becomes the Hikurangi Trough and the Kermadec Trench. That's all the plate boundary. The North Island is on the Australian plate. Most of the South Island is on the Pacific plate, and these two plates are colliding with each other and grinding past each other along that boundary. And that's our modern situation. It gives us uplifted mountain ranges, it gives us earthquakes, we still have active volcanoes, so we have this huge active landscape in continual formation. It's not stopped, it's been doing this for millions of years, and it's still in that process today. So that is a summary of this epic history of the rocks that we have right through New Zealand. That's the story of our New Zealand Greywacke, and the story it contains, its deep history from the past in Gondwana through to the separation of Zealandia, the drowning of Zealandia in the ocean, and then its uplift to form the landmass of New Zealand that we have today.